Okay, everybody, welcome to today's class, and we're going to continue with Chapter 2, Graphing and Charts. So we are on the qualitative data graphs. We've talked a little bit about it. The key point about qualitative data is that it does not come with pre-established ordering, the way numbers are. When you're counting, from negative infinity to positive infinity. And that's the order of the numbers. And bar charts can also be used to graph qualitative data. And the y-axis displays the frequency and the x-axis displays the categories. So the categories on the bottom are horizontal and the frequencies on the y category. Now I'm going to show a video. And I'm going to just try something. Hopefully it'll work. If you have any questions with regards to the video, please put up your hand and I'll stop the video and you can ask your question and we can discuss it. Okay, so I'm going to start the video. Sorry.
To talk about how to organize qualitative data. Qualitative data, if you recall, we'll try to put the link above for how we identified those types of data from section 1.2. But qualitative data is basically that root quality, just a characteristic. And so no numerical values here that are measuring any quantity or weighing any shape. So we'll talk about tables and a couple of graphs that you'll recognize. So in terms of organizing it, two types of tables. We'll have a frequency table, which is essentially a count, and relative frequency, which is...
Sorry, does this sound better now? Can I just get anybody to say yes, no? Okay, let me try to make it a little louder.
A proportion relative to the whole. And then we've got some graphs.
Hey, how's that? Okay, sorry. Continue.
Here, the Pareto charts. Excuse me, might not sound familiar, but it's basically a bar graph that's ordered. So we're going to use some data. If you want to follow along, I have this body image data linked in our course group in StatCrunch. So I'm going to see if I can switch over to that. Oh, yeah, there's my wife. And my boy is, where is it? There we go. All right. So I've got this body image data set in StatCrunch. If you look in our group in StatCrunch, go to my StatCrunch.
And by the way, if people have been using their Pearson, StatCrunch is exactly what they use for their graphics.
And my groups, and you'll see the group that you hopefully joined already. Within it is the body image data set. And so I wanted to do a count of this body image data set. It was a group of students, and they were asked some questions. And one thing that they were asked that was measured about them was where they sit, front of the room, middle of the room, or back of the room. So we have this seat data here. Can I zoom in? No, not really. I'm used to using like a control zoom here. So can't really zoom in, make it easier to see, but front, middle, back. And so one comment here that I thought I should mention, normally the ways that you can order your graph would be alphabetical. Those are the only options you could do, but I actually added a new ordering here. I just learned how to do this. So I added a new ordering. If you go under orderings, they have these standard orderings. These are in every StatCrunch file, has these standard order, but you could add a new one, and I just learned how to do this. So I'm going to order. The problem here, let me back up. So if we go to stat, tables, and frequency table, that's what we want to do. We want to make a frequency table. Then we just select the column that we want to do, seat. We see here seat more than the middle and I want to do a frequency table and a relative frequency table. So if I hit compute, you can see the ordering here is just alphabetically B, F, M, back, front, middle, but that doesn't really make sense. You can reorder it, but it's going to be alphabetical, either MFB or BFM, which you could reorder if you type it into a Word document or something, but it doesn't really make sense.
So I just want to point out that remember when you're looking at the data files in SIN, this is what you're using, StatCrunch. So it's probably a good idea, to pay somewhat attention to what he's doing, because then you can organize your data in the way that you would like it to look.
So I am going to go under Edit Orderings, and you can make your own new ordering. So I'm just going to add a new ordering and just call it kind of the logical order, front, back. And update, close. And then now, if I close this and do it again, stat, tables, frequency, and click seat again, now you will see front, middle, back. So if there's ever an ordering where the alphabetic one doesn't really make sense and you want to do a different order within StatCrunch, you can go to Edit Orderings and make your own custom one. So what I want to do now, I'm just going to copy this for now. And I think when it's text like this, just copy. And let's see if we can jump back. So what I want to do now is I want to type in here. You're going to see StatCrunch again, but I'm actually typing in on the other side. So 52, 137, and 47. And so I've got those typed in, and now that I have a frequency table. So those are my categories, and those are the frequencies, which are just the counts. And so now, let me see here. I'm going to pause the video for a second. All right, now that we have that, let's make a relative frequency table. And so we could do this by hand. We could calculate the total frequencies, which, let's see if I can pull out my calculator here. It's like 2016 when I'm recording this. Who actually uses a calculator anymore? But we could do 52 plus 137 plus 47. 237, and divide each of these by 236. But you may have noticed that StatCrunch already did that for us. Can we find that? There we go. So they already have the relative frequencies there for us. And so let me see if we can enter those in. We've got, I like to round to the hundredths place, like percent. So 0.22, 0.58. And I think this video is not going to be as short as I thought it was going to be because I'm doing some of the StatCrunch stuff, but the relative frequency. So that's just relative out of the whole. And you want to, if you're using StatCrunch, you want to round these all to a consistent decimal point. So that's frequency and relative frequency tables. Next, a bar graph. Perhaps you're used to these where you have the categories along the bottom and then the frequencies vertically, and StatCrunch can do all of this for us. So if we go to graph, bar plot, we have data here. We have the raw data, so we want to choose with data. And we want seat. And we have a type here. Do we want to choose frequency or relative frequency? So if we choose frequency, I'm actually going to kind of resize this so it's in a convenient shape here. If you want to copy this, you can't really right-click. You can right-click and save the image. But if you go to copy, you can right-click and copy this now, but it's a little tedious to paste. You have to follow these directions here. You can see to paste into Word or PowerPoint, you have to paste special. Do this device-independent bitmap. It's a little annoying.
I just want to ask anybody, is there something missing in this graph? Like, what is it that you're not aware of? I'm at least not aware of. Anyone? Okay, so say you were looking, yeah, exactly, detail, the subject. I mean, it's very nice that the program can create this, and I have not used this program, just to tell you the truth about it. if somebody is coming to class and this graph was up on the wall or, on the video, FMB doesn't mean anything to me. So as I tried to point out to some people who I've returned their homework to, you've got to be very complete when you're doing any kind of graphic, whether it's a pie chart, whether it's a line graph. You have to have a title, you have to have an explanation of what your variables are, like FMB doesn't mean anything to me. So just as an aside, when you are doing graphs and charts, to show much detail about the graph so that when someone looks at it, they're able to understand it clearly. Okay, we'll just carry on.
So if we go back over here to my PowerPoint, probably should have had this viewable so you could see what I was doing, but there's our graph pasted in there. That's a frequency bar graph. Relative frequency, same thing. We would just, in fact, you can go back to these options and change it from frequency to relative frequency. And it's just going to be the vertical scale is going to be relative frequency now instead of frequency. And again, you could copy that, right click, copy image, and then in your PowerPoint, no, you're not going to do PowerPoint, but in your, if you're going to make a Word document or something for your project, you have to do that. You have to do that special paste where you have to do device independent bitmap. It's a little annoying. First couple of times you do it, it'll be a little tedious. I wonder if I can actually show you how I did that. Let me see here. Put this over here on your side. So the way that I did that paste is I went to, and you can do this in Word, to paste, and then you paste special, and then you choose device independent bitmap. So if you're doing this in a Word document, say for your project, that's how you would paste it in there. It's, again, I'm sorry about that. It's a little tedious, but it is what it is. So next, let's do a pie chart, and we'll go back over here. And again, StatCrunch. It's going to be a little intimidating at first, but pretty straightforward. We'll just do pie chart. A lot of menus. Just got to choose the right menu. With data, we'll do seat again. There are some options here about what you can display. Do you want to display the count or just the percent? I'm really usually just interested in the percent. So I'm going to hit compute, and there is your fancy chart. And again, you can do options copy and do the special paste option there, like so. Okay, so pie charts, bar graphs, you've seen those before, you know how to make them. Hopefully the StatCrunch instructions were helpful. This graph you saw a little bit earlier, very important pie graph. Everybody needs to know this. I'm kind of dating myself, but hopefully you at least know who Pac-Man was. All right, so key points here from this first section, 2.1. We've got frequency, which is just the count, how many are there, and then relative frequency is basically the percent, what percent of the total. So you take the count over the total. We have bar graphs, which are, in this case, I've got this like feeling about weight from some other context here. And by the way, I mentioned earlier the Pareto chart. The Pareto chart is just ordered by frequency, so they're highest to lowest. So bar graphs and pie charts, and those are the main graphs from this section. So thanks for watching. If you have any comments, you can place them below in the comment section.
Okay. So let's just, well, it's already in, somebody asked whether we can post the video. The video is already embedded within the PowerPoint for the Chapter 2 PowerPoint. So it's already there. Okay. Sorry, every time I go back, I have to go down to the, okay. So in a pie chart, which he talked about a little bit, and I guess that was more of a lesson about StatCrunch. So You can follow along if you're going to do your graphs in StatCrunch, or you can do it in Excel. The pie chart is a type of graph that displays data in a circular graph, and the pieces of the graph are proportional to the fraction of the whole in each category. As mentioned previously, it always adds up to 1 or 100%. You know there's something wrong if you go over that number. So, in other words, each slice of the pie is relative to the size of the category in the group as a whole. And in the chart that's on the screen, it shows water usage, and this is American. The EPA is Environmental Protection Agency. So you can see the use of water according to what people said they use water. And what I'm going to try to do now is show the video on the pie chart. Sorry, my computer is slow again. Anybody willing to buy me a new one, I'd be very happy.
Common and which one?
And
Ones are less common. Kind of like when you grab a pie and you want a piece of it, you can take a small piece or a large piece, if you like the pie, of course. And so you get that same kind of feeling with a pie chart. But it becomes less effective when the data types become large. For example, here may be a survey that was done to find out what the students would like to graduate as, or with what kind of degree they would like to graduate with, or perhaps the totality of all the students in the college.
so I just want to point out here that as he mentioned in the video, when you have a pie chart, let's just say more than 5 categories, it seems rather silly to present a pie chart that large. That it just is very messy. Your viewer, your reader is going to get confused because there's so many categories and so many percentages that really you don't want to strain your brain to like process this information. So remember, if you're doing a pie chart, I would say maybe the maximum number of categories you're going to use, maybe 8. I would say max 5, but it just makes it cleaner for your reader, your viewer to look at. Any questions about that? No? Okay.
And so as a percentage, you can see that more want to graduate a business degree and less with biological sciences degree. But notice that if there's a lot of data types, begin to lose the ability to compare one by the other strictly by the size of the slices in the pie. And you actually have to start reading the numbers, the percentages, in order to get a feel for how big that slice actually is relative to the others. So pie charts, they tend to work better with fewer data types. They tend to work not quite as good with large data types, unless there's a big difference between the parts that are very common or very popular versus the one that's just a few of. If you can readily see a big difference in the size of each slice, then it becomes a very useful type of graph. If there's a lot of data types like this, and the differences between them is relatively minor, for example, we have 8%, 12, 8, 10, 10, 12, 9, it becomes very difficult just by looking at the pie to identify the size of each slice. And maybe a bar graph then where you can see the literal height of each data type becomes a little bit more useful in that particular case. Either way, you can see here there's a certain benefit and a certain amount of visual, I would say visual relationship to what we're used to when we see a real pie versus a data graph like this. That's why they will always be around.
Okay. Okay, so continuing with the pie chart, here's an example of a very bad pie chart. There's way too many categories. But as said, it provides a snapshot of how a group is broken down into smaller slices or pieces. The following chart shows what New Yorkers throw in their trash cans. You can read that New Yorkers, perhaps surprisingly, throw a lot of recyclables into their trash, but a pie graph gives a clear picture of a large percentage of recyclables that find their way into the trash. Now, can anybody tell me how to make this pie chart a little more readable? How would you think that you can make it more readable for the audience? Anyone? A legend, yeah, that's one way. Okay. Can you think of anything else? Okay, and how do you get less categories in here? What do you have to do? Can you think of what you need to do? Make a table, that's one thing, but you're still not making it readable. Yeah, how do you combine them together? What are you doing to combine some of the categories? You got the idea. Look at the chart. Look at what, things that are similar. No, we're looking at the pie chart, John, not a bar chart. We're not going to add a bar chart. We want to use the pie chart. Okay, so tell me something. We have recycling. We can put like all the recycling material together. Right, Olga. Group it with the same meaning. Okay. If you want it broken down, what would be better is to have a bar chart. But in the pie chart, maybe we have, recycling, non-recycling, toxic, non-toxic. So we're going to reduce the number of categories and what's called collapsing the data. You have 100 categories. That's way too much. So we want to collapse the categories. So maybe we only have 10 categories or 5 categories. You can always expand them after. But as pointed out in the video, doing a pie chart and having so many categories is difficult for you as the presenter to present it, and the people who are listening to your report or you're presenting it to them make it difficult for them to understand it. So does anyone not understand the concept of collapsing the data? Okay, everybody's got that. Okay, great. All right, so the bar chart. The bar chart is the graph with rectangular bars. Each bar's length or height is proportional to the bar's represented values. In other words, the length or height of the bar is equal to the quantity within that category. Usually it's a percentage. because percentages are easier for your audience to understand as opposed to a raw number, because a raw number means nothing to them. And the graph usually shows a comparison between different categories. Although the graphs can technically be plotted vertically or horizontally, the most usual presentation for a bar graph is vertical. The x-axis represents the categories, the y-axis represents a value for those categories. In this particular graph on the screen, the values are percentages, which I personally think is a lot easier to understand as opposed to a raw number. You can have both, but the percentages make more sense. Remember, when you're creating these graphs or charts, it's always for the audience in mind. You always want to make it easy for them to understand what you're trying to communicate to them or convey what information. Okay, so let me just go back here and look at the
In this video.
All right, sorry, I'm going to change it to the video. All right.
We will learn all about bar graphs, also called bar charts. Bar graphs are used to display categorical data. That is, data that you have that is broken down into categories. The categories could be numerical, but more often they are qualitative, like something like colors or different places, like different states, something like that. When making a bar graph, you'll have different bars for each of your categories, and the length of the bar will correspond to the value for that category or the frequency of that category. The bars can be horizontal or vertical depending on your preference. For example, we could make a bar graph for the number of students in different electives or extracurriculars at your school. The different extracurriculars would be your categories, and the different heights of the bars would be based on how many students are in each of those. So if you want to make a bar graph, you should first set up your axes. You're really going to be working in one quadrant. Then decide on your categories. So in this case, let's just pick 3 categories: sports, music, and drama. Then you need to know how many people fit into each category. So let's say we had sports was 20 people, music was 15 people, and drama was 10 people, just for an example. So once you see what your numbers are, you can scale your y-axis accordingly. So we would need to go up to about 20. So we can go by 5s. And then you want to make it.
Now I'm going to stop because I just want to mention something, and this is my own personal bias. When you are creating a graph and you have your vertical axis, which is the number or the percentages, you don't want to give the max number as the max number of one of your categories, because then it would just be at the edge of the graph. So in this case, she's got 5 to 25 with 5 as an interval. So I would go from 5 to 30 because then it leaves some space on your graph without basically compacting it. So just my experience with graphs.
A different bar for each of your categories. So for sports, we need to go up to 20. So we're going to make a bar that goes up to 20.
Oh, I apologize. She did do that.
One important thing is that your bars should not touch, and all of the bars should be the same width. So then for music, we're going up to 15. Notice how the two bars are not touching and they're approximately the same width. And then for drama, we go up to 10. So this is a basic example of a bar graph. Again, as I've said, the two most important things is that the widths of all of your bars are the same and there has to be a space between the bars. This is because the data is categorical and it doesn't really make sense to think about sports and music being connected. It's almost as if they're in different graphs altogether. They're representing completely different things, but we just want to compare the numbers for each of those three things.
Okay, I'm going to stop because, again, when you are creating your graphs or charts, first of all, you need a title, and that title has to be clear. You can do that, but you also have to have an explanation. Amir asks, isn't it better to put the number inside the bars more readable? Yeah, but you also have to have the vertical scale. The number does tell you what that specific category has or what is assigned, right? But you have to have a title as well to be clear in your explanation about what is this graph showing me. Now, can anybody tell me anything about this graph? Can you get some information out of here? Nobody can get any information from this graph. No, I think it's a preference, or well, maybe she didn't explain it. People enjoy more sports. Right. And what else do you know, Wellington? Exactly. Exactly. Okay, so that's what I want you to do. Remember, I want you to think about things in a statistical perspective. I want you to get as much out of the data as possible. Okay, so we know that sports is more preferable, and we know that drama is the least preferable, and music is sort of in the middle between the two of them. Okay, we haven't talked about any kind of statistical significance or anything like that, but from graphs, you can say those things because this is a graphical representation of the data. So you can, infer something from the data without running an analysis because you're looking at the raw numbers here. Okay, so that's how I want you to think when you see these things or when you are creating them. Important to look at the whole picture.
But it's not a continuous set of data. The last thing that you should do is label your axes with what they represent. So we would say our x-axis is our extracurriculars, and our y-axis is the number of students. Now you could have made this bar graph completely flipped. It would really be up to you if you wanted to do that. It would just mean that you're switching where your frequencies, the number of students were, and where the extracurriculars were. So it would look like this, and we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we would have number of students here, and we would have number of extracurriculars here. And we and the extracurriculars here. And we would have just had sports, music, drama, and it would have looked, you know, something like this. So you'll see bar graphs both ways, and it's really up to you how you want to make them. There's no...
Can I just ask people, which one is preferable to you, or which one is easier for you to understand the information? The one where the bars are vertical or the bars are horizontal? Okay. Okay, the majority that have answered think it's where the bars are vertical. Okay, I think that's just sort of like something that's part of our brain processing. It makes it easier. We like that. The other one may look weird to you. You know, maybe depending on your cultural background or what you're used to. Anyways, we'll go back. Okay, so continuing with the bar chart. A bar graph is useful for looking at a set of data and making comparisons. That's basically what it's used for. So for example, it's easy to see which items are taking the largest chunk of your budget by glancing at the above chart rather than looking at a set of numbers. If most of you, if the majority of the people in the class are going to be accountants, or going to work in accounting, this becomes very important. And because the bar charts are easier to read, as I said, then you can talk about it very quickly. You can respond to this unless you're actually the one that's creating the charts. So bar charts can also represent more complex categories with stacked bar charts or group bar charts. So for example, if you had two houses and needed budgets for each, you could plot them on the same x-axis with a group bar chart using different colors to represent each house. In this bar chart, we have physicians working with at least one nurse practitioner, certified nurse midwife, or a physician assistant by practice size. And you see this is probably a better well-designed chart. You have a title at the top. You have a legend that tells you what the colors represent. And then at the bottom on the horizontal axis, you have the different categories: primary care specialists, surgical specialties, and medical specialties. And you have, I believe those are percentages there. You can't see it that clear. But this is the kind of chart you can readily use for comparisons, and that's what you're trying to do. You're trying to compare different categories. So, anybody have any questions about this? Everybody clear with this? All right. And then we have scatter diagrams. Scatter plots, also called scatter graphs, are similar to line graphs. A line graph uses a line on the XY axis to plot a continuous function. That's important. That means it is continuing. While a scatter plot uses dots to represent individual pieces of data. In statistics, these plots are useful to see if two variables are related to each other. So for example, a scatter chart can suggest a linear relationship or a straight line. So let me just go back here and I will get the video for that.
In this video,
Okay, sorry, I've got to change up.
we will learn all about bar graphs, also called bar graphs. Bar graphs.
Oh, sorry. You know what? This is the same one.
Data.
I apologize. Sorry, my memory's gone. Anyways, I apologize. Okay. We'll try this again. Oh, it's the same one. That's weird. Okay. And it's kind of weird. I don't have where the video is. Nope. I apologize, everybody. I thought I had a video. Anyways. But just look at this. So you see here, we've got the dots placed here, but realistically, there are dots at every point on this graph. And as mentioned previously, line graphs are continuous. So we're starting from over here in 2007, and we are going here to 2012. And basically, the graph is showing you whatever data it's looking at, how it reacts on this continuous basis. Okay, so if you were measuring something every day, whatever, you could say, what's the oil consumption of cars at, gas station A? And you could look at the oil consumption, connect the dots. You've got a continuous graph. You can find the mean, the mode, the median, do standard deviation, the variance, so it can give you all that kind of information. And let me just see here. Sorry, Amir is saying, can we predict what will happen to the graph? When you mean, can you just elaborate on that? What do you mean by that? When you say predict what will happen, are you talking about the category that you're measuring? Well, that's what people do. So Amir has said, like stocks or whatever. That's what people do. Now, there's more, shall I say, more parameters involved when you're doing prediction. And in statistics, it's referred to as regression, because you have all this data from the past and you're going to predict what's going to happen in the future. Sorry. Now, that's what people who invest in the stock market try to do. The problem is they're not telling you, well, if there is anybody in the class that has invested money in the market, and we're talking about statistics here, so we're talking about trying to be more precise. We want to get information. It's your money. You want to be able to invest it so you know that you're getting a return and it's not a guessing game. So when you predict, you have to listen very carefully about what the stockbroker is telling you. You know, are they using 6 months of data? Are they using 6 years of data? Where's this data coming from? So making predictions, as I tried to emphasize for your case study, you want to be as accurate and precise as possible when making a prediction. Okay, so you have to have lots of data. You know, 6 months of data, that's not very much. And why is it only 6 months? What happened, you know, the previous 10 years? What's going on? Or have there been changes? We probably will look at that a little bit. We'll look at some graphs in the stock market, but not till we start talking about regression analysis. Okay? Is that all right? Because you have to understand what goes into coming up with regression analysis. So is everybody good with that? All right. Okay. And I'm going to try another one, and let's see if this one works. Not sure why there's no video there, but we'll try it again. Well, that's interesting. Not sure why that happened. It appears the videos are talking more about math than it is about the statistics. And I'm not sure why. Yeah, well, that came out to a calculus video. So I apologize, everybody. Just trying to get this. We'll try this one more. Okay, now hopefully this will work.
This is Stephanie from statisticshowto.com, and in this video tutorial I'll be showing you how to get a linear regression equation. There are several ways you can get a regression equation, and there's a couple of links below this video in the description field. You can find links to an online linear regression calculator and also an article on how to get a regression equation in Excel. But if you have to do it by hand for a statistics class, here's how to do it. I'm going to find a linear regression equation for X and Y values related to a study on pre-diabetic patients. I have the age of my participants, that's the X value. Okay,
so just for those that have never heard of regression, basically what regression is you have a number of variables independent, the independent variable, and we have a dependent variable. And what we want to say is, as Amir asked, can we predict from the stock market? So you have all these conditions which are considered X variables, and then you have the dependent variable Y, and we take all the values of the X and we come up with a prediction for Y. So that is in essence what a regression is. We're only going to cover it not that much, but so you're aware of it. Anybody that's taking STAT1010, that is one of the essential formulas that are going to be used in that class.
and the glucose levels, that's my Y value. I've put them into a table format. I've put the ages, the X's in one column, the glucose levels, Y, in another column, and I've also added 3 more columns, XY, X squared, and Y squared. I'll explain how to fill those in just a moment. This is the summation symbol. We're basically going to add everything up in every column. So I'm going to start adding my X values. If I add up my X values, if I add 43, 21, 25, and so on down the column, I get 247.
Don't worry about these
values,
formulas.
I get 486. We're going to fill in the XY column. We're just going to multiply X and Y. So 43 times 99 is 4,257. 21 times 65, 1365. And I'm going to zip down the column, just filling in these XYs. And finally, in this bottom row, we're going to add everything up. It's the summation row, so we're going to add up all of these values in the XY column. And when you do that, you get 20,485. The XY column, we're going to square our X value. So the square of 43 is 43 times 43. It's 1,849. And working our way down, square of 21 is 441, and so on down the column, 625, 1764, and our last value, 59 squared, is 3,481. I'm going to add all of these up, and I get 11,409. Final column is a Y squared column. I'm going to square our glucose levels, our Y levels, so 99 squared is 9801. Just working my way down.
Tedious, isn't it?
Y values.
That's why we have computers.
Going to add up all the Y squared values. Next, I'm going to use these equations for a linear regression. They might look a little ugly, but we've already got the values in this last.
So I just want to point out, this is an equation you will never, well, not in this class, you will never have to do by hand. Okay? You're going to do it. You're going to do it on the computer or your calculator. Those two options.
Summation column here. The sum of Y is right here. This is the sum of X.
Yes, it's scary.
The sum of XY. The sum of X squared. And the sum of our Y squareds. I'm going to work through A first. So the sum of Y. $486. The sum of X squared, 11,409. Subtract the sum of X, 247. Multiplied by the sum of XY, 20,485. This is all going to be over. N, well, N is just how many we had in our data set. We had 6 subjects. Multiply that by the sum of X squared, 11,409.
Okay, a quick question. She had an N of 6. Is that sufficient? I know we haven't talked about sample size, but do you think that's sufficient? Anybody? No? No? Anybody else still awake? Okay, no. A sample size of 6 is terrible. because it can really skew your results and give you a false positive, which means you think it might be statistically significant, but in reality, it isn't. So just remember that.
Subtract the sum of x, and then the sum of x is going to be squared. So 247 squared.
Quite the formula.
Plug this into the calculator, we get 65.14. So A is 65.14. Now we're going to work on this B equation, starting with n multiplied by the sum of xy. So you have n, 6, multiplied by the sum of xy, 20,485. I'm going to subtract sum of x multiplied by the sum of y, 247 times 486. And this is all over n is 6 again, multiplied by sum of x squared minus the sum of x squared. That equals 2,868 divided by 7,445, which gives us 0.385225, and that's B. So we found our A, and now we found our B. The linear regression equation is y equals a plus bx. So we're going to plug our values in. So we have A, 65.14, plus B, 0.385225, x. And this is our linear regression equation. This is Stephanie from statisticshowto.com.
Okay, so remember you'll have to memorize that formula. Not really. Okay. So actually, that brings us to, I believe, it's the end of chapter 2. Just to make sure. Yeah, that's the end of chapter 2. And just to go back to the scatter diagrams, is if you've seen them, they look like there's a bunch of flies or wasps or bees on a graph, and there's like some are very dense and some are very light, and it can tells you where the concentration of your data is. All right, so that's the end of chapter 2. And what I'm going to do is the chapter 2 test will be on Friday. So what's scatter for you? What's scatter for? I'm not sure what you're saying. Can you be a little clearer with that question, Amir? Amir? Okay. What you want to do is basically it's the beginning of a data analysis. And so you have, now think about it. Remember, there was one video in the last class where the guy was talking about data mining. Okay, so you do a transaction with a debit card. So how many transactions may occur in one day? Millions, correct? So initially, I want to see where's the focus of the data. And all the dots are going to be put on a graph. And maybe they're, focused in the right-hand upper corner. So I'm going to look at that corner. I'm going to go, what's going on here? Whereas the other dots are scattered around the graph, sort of not evenly, but not that there's a concentration of them. So it looks darker than the rest of the graph, right? There's more points, okay? That tells me that I can go and look at that particular area and focus on that area as opposed to the other areas which does not have as much density. So we can throw those out and focus on the denser areas where whatever the activity you're measuring is going to be evaluated. Does that make sense to you, Amir? Does that make sense to everybody? Amir? Linear? You mean linear graphs or whatever? What is whatever? You got to be. This is stats. You got to be more precise, Amir. Okay. So are you trying to say that you don't see those graphs? That's not what's published. That may be in-house when they may do a scatter graph at the beginning. As I said, it's for investigation. We don't know anything about the data. We want to look at it from the beginning. So we're going to investigate it. And a scatter graph gives you a preliminary idea of where the data is concentrated. Okay, where the data is not concentrated, there's less activity. So any other questions? Okay, no other questions. Okay, so as I said, test 2, I will make it available Friday, again from 5 p.m. to Monday 5 p.m. Okay, and it's the same design. It's going to be, you know, multiple choice, fill in the blank, short answers. All right. So in light of that, and of course you're not obligated to come, for tomorrow's office hours, if you have any questions or any queries or any confusion about the topics in chapter 2, you know, come to the session 10 to 12 and we can talk about that. Yeah, I'm going to get to that. I'm still focusing on chapter 2. So just to let you know, 10 to 12 tomorrow, we can do a review of chapter 2 and the concepts that are part of that. All right. Okay. So Amir has asked me about chapter 1, the test. So what I want to say is the mean for chapter 1 was 80.03%. And the standard deviation was 11.66. Okay, so that tells me, or maybe you can tell me what that means. Can anyone tell me what those numbers mean? Anybody? No? Most students did great? Okay. Well, they did better than 50%, obviously. Okay, if the mean was 80% and the standard deviation was 11%, okay, that means if it's a normal curve, most of the students went from like a low of like about 69 to 91. And then we have the other students outside on either part of the curve. So yes, well done. And Kavita, you can do better, okay? So I'm going to expect a perfect from you next time for test 2. Okay, sure. All right, that's fine. Okay. Any other questions about test 1? And Kavita's the only one that answered. Okay, that's good. All right, I also want to mention that what I'd like for everybody to do, and if this is with your case study, I would like you to present your case study to the class, as well as handing it in, as a report or your research. But I'd like everybody to be able to present their case study, and it will probably be near the end of the. Okay, Siddhartha, you have a question.
Hi, sir. So I just wanted to ask, so for the case studies, I noticed there were multiple different, I was a little confused on how I was supposed to go about doing that assignment. And I noticed under each case study, like data that was available to us on Blackboard, there's a different assignment sheet. So does it depend on which data sheet we decide to go with, and then we do the assignment for that data sheet?
Yeah. Well, okay, so the first thing is you will tell me which case study you want to do. And if it's one of the ones that the data is already there, I believe that you're talking about the sheet where it says answer these questions or answer these queries about the data.
I'm talking about when you go like on Blackboard and it says case studies, and then when I
Yeah.
click on case studies, there are like 5 different options in different colors, right? So suppose
Those are different data sets.
Oh, so then what are we supposed to pick?
You pick whatever one you want.
Out of any of them?
Yes. Or if you were not here, I said that you can collect your own data
And then run it by you, right?
and run it by me. I gave you an example, or I sent an example about a very poor research design. And I just quickly mentioned it. It was like, I'm gonna count how many, I can't remember, how many cars are parked illegally on a street. That's not a research proposal.
Okay. So my
Go
question is that suppose I select Toronto approved operating budget 2017. When I click on it, there's a specific assignment for that data sheet.
Oh,
So
yes, there is. Yes.
okay, so each data sheet has its own specific assignment, correct?
Correct.
Okay,
Correct.
so whichever one I pick, I do that assignment. Got it.
Yeah, but as I said, if you want to select your own data,
I do that too.
you can do that too, but you have to talk to me about it.
Okay. And
Okay.
if I select my own data, how do I go about the assignment then? Would you create an assignment specifically for my data?
Well, that's what we have to discuss.
Okay.
Because
Perfect.
I have to know, the question is, most of the data, most of it, it's mixed. There's some categorical data and there's some continuous data, right? Or discrete and continuous.
Yeah.
So you want to be able to evaluate all the data. You don't want to focus on one or the other, right? So you got to do some analysis of the categorical data. You got to do some analysis of the continuous data.
Got it. Thank you.
Right? Okay. And when is the case studies due? Kavita. So the proposal I said was due. I believe I said that it was due intersession week, which is week 8. You got to send me your research proposal, but before that, if you've got questions, please send them to me. Because has anybody in the class had experience with writing research or writing a science report or something like that? Yeah, Siddhartha, yes. No? Okay, so it's mixed. So maybe during the office hours, for those people that are not familiar with that, we can talk about that. And no, John, you don't have to have a PowerPoint with your study, but you're going to do a presentation, so it's easier for you to do a PowerPoint as opposed to just reading it. Okay? Anyways, so any other questions about that? No? Okay, so we're going to start chapter 3. And okay. Does anybody know that? Oh, does anybody know what this is? Mu, right. And what's mu again? The mean. It's the population mean, right? So, I mean, the mean is saying it just seems that no matter what I do, I'm always just average, right? Because that's the definition of mu. That's the population average. Sample average is X, or the X bar. Okay, sorry, I want to get an idea. How many people have not? You know what? Let me do. I'm going to do a. Let's see. I'm going to do a poll, and I want to see. Um, so I'm asking a question. How many people have done some work with mean, median, and mode? So please indicate your answers. So try to answer the question because I want to get a somewhat understanding of the class makeup with regard to this. Okay, there's still 7 people. Do the poll. And it can't be not applicable. 6 people. 5. Okay, 5 people. Please vote. There are 5 people out there that haven't voted. Please vote. Is there a problem with the people not voting? Can you tell me the people who have not responded, why are you not responding? Okay, there's one. There's 4 left. We can't continue unless everybody votes. 4 people. Can you please put up your hand if you haven't voted? Nobody wants to admit it. Okay. Hello, everybody. You're holding up the rest of the class, you 4 people. Well, maybe they've left. Who knows? But according to the numbers here, there's still 24 here in the class. Okay. What should we do with these 4 people? Any ideas? No ideas from anybody. Okay. Why do I take, okay. Ban them. How about I just give them 0? How's that? How's that? Is that good? Oh, somebody came through. 3 people left now. But it's not fair. All right. Well, it's fair, John. They're holding up the class. Why? Either they've worked with the mean and the median and the mode, or they haven't. Why can't they respond? You're telling me you don't know what the mean is? Maybe they're not actually here. Well, maybe they're not. Maybe they've got somebody else pretending to be them. They're not following the lesson. Yeah, that's a possibility. Okay, so I don't want to keep this going, but 10 people said yes, 11 people said no, and 3 no respondents. So as I think it was Jansen said, take it as a no. That's exactly what I'm going to do. So we have almost a split class. 10 yes, 11 no, 3 no response. So you usually take that as a no. So we got 10 people who have experienced with central tendency and 14 people that have no experience. All right, so that gives me an idea that the people have had no experience. This is the most important part of statistics. No matter what somebody says, it is the most important, because when you are doing data analysis, you are always comparing one group with another, and usually what you're doing, if it's continuous data, you are looking at the differences in the means, okay? Because that tells you, is this group from a different population? Oh, another person voted. Oh, no, they left. Okay. Or is it from the same population? And it becomes very important when you are selecting information. Ahmed left, okay. When you are selecting information to analyze, you have to know what group this data comes from. Is it a totally different group, or is it from the same group? And that's why understanding the measures of central tendency is extremely important in data analysis. Okay, so having said that, let's continue. Okay, So here are the objectives of this chapter. Calculate the arithmetic mean, the weighted mean, the median, the mode, and the geometric mean. I will tell you right now, unless, of course, somebody is doing some kind of analysis for their case study that involves the geometric mean or the weighted mean, you don't use those very often. Okay? And the second objective is explain the characteristics, uses, advantages, and disadvantages of each measure of location. So where is this data relative to other data? The third objective, identify the position of the mean, the median, and the mode for both symmetric and skewed distributions. Number 4, compute and interpret the range, mean deviation, variance, and the standard deviation. Number 5, understand the characteristics, uses, advantages, and disadvantages of each measure of dispersion. And number 6, can somebody pronounce that name? I'll give you a bonus mark if you can. Understand whose theorem? Okay, John.
Chebyshev's.
Oh my God, you got it correct. You must have done this before. No? Yes, you're right. Chebyshev's theorem and the empirical rule as they relate to a set of observations. There we go. I better, you know what? I guess I should change the the scheme for the course and make it more like a game show, and people will bid for marks. How's that? Does that make more sense? Okay. So we talked about this before, parameter versus statistics. And that's too risky. All right. Okay, so the parameter is a measurable characteristic of a population, and a statistic is a measurable characteristic of a sample. And we talked about that before. Just hold on a second. Okay. That's too risky. Good if it's a bonus mark. Yeah, it's a bonus mark. Okay. So let me I'm not sure if we did this already.
Lene is campaigning for town mayor. Today she is doing a little market research to understand the concerns of people in her town. In order to collect this information, Lene will have to understand parameters and statistics when working with populations. In this data, you will learn about the differences between parameters and statistics when working with data. But first, let's review populations and samples. A population is all members of a specified group. For example, in Lene's case, she is collecting data on a very literal population, the population of her town. All members of this town would be included in the population. However, most of the time it isn't practical.
Okay, so I'm going to go slow for those people that really say they have not had any exposure to the measures of central tendency. Does everybody understand the concept of a population? Is there somebody that doesn't? Please say something. Okay, so the population is the population, it's everybody. Okay, John. I'm asking if anybody doesn't know what a population is in statistical terms. Okay, so everybody seems to know what a population is. Good.
To get information from every member of a population. When this happens, we have to find a different way of getting information that represents the population without actually asking the whole population. Lene will probably not have the time and the resources to collect information from the entire town. Therefore, she will need to gather another approach to getting the information she needs. She will need a sample to gather this information. A sample is a part of a population used to describe the whole group. For example, Lene could go to a local event or mail out surveys to the people in her town.
Okay. This is a sample. You know what? I'll ask the question afterwards.
As long as the information she collects is from the town and not a neighboring community, then this can count as Lene's sample group. Samples are used to help the data researcher, in this case Lene, to understand the entire population. There are many different ways you can get a sample from your population. These include random sampling, simple random sampling, cluster sampling, stratified sampling, and systematic sampling.
Okay. Sorry about that. Okay. So my question is, somebody is running for mayor of the town. They're going to get people's opinions or information about them. Can someone tell me what a representative population is? Anybody? Those people that know about if you're doing a survey. I want a representation of my survey of the whole town. So what do I need to do? No one? Have you not participated? I have not participated in a survey before? What are the kind of questions they ask you? The number of people in the family. Yeah, that's one. Your age, correct. Right, how old you are. Anything else? Right, level of education. What else is there? Your level of income, correct. So when you ask those questions, they are what are referred to as demographic questions, right? They want to get a general picture of who you are. Are you a male? Are you a female? Are you a student? Are you a full-time worker? Okay. In some cases, they don't ask you specifically what your income is. They ask you, as Kwok has pointed out, your level of income. You know, do you earn between, $0 and $1 million? Do you earn more than $1 million? Whatever the categories are. So you're getting a demographic of the population, and you want that to be representative of the population. So you don't want more females than males. You don't want people who are all, post-secondary educated. You don't want people who are all millionaires. Yep, your birth date, how old you are. They want to know whether, in some cases, are you born in Canada or you're not born in Canada? This way, what happens is when we're doing the sample and say You know, somebody, for example, somebody is running for mayor of Toronto. So we have different sort of ethnic groups in the city, right? You have like Greek town, where there's a higher percentage of people from Greek origin who live there, all right? You have other areas where there are different ethnicities. And what you want to do is you want to capture information from all those different groups. Because if you don't, then one, your survey is a bad instrument. It's not measuring what it's supposed to measure because you don't have a representation of all the groups in whatever you're measuring. In this case, you're measuring a survey of people running for mayor. What are their concerns? That's a different thing. That's your survey. But to get your initial data, you want to capture as many diversities as possible that exist within what you're measuring, in this case, like in the city. So does anybody not understand that? So everybody understands that. Okay. Okay, good. All right. So for ungrouped data, we'll talk about group data. The population mean is the sum of all the population values divided by the total number of the population values. And the sample mean is the sum of all sample values divided by the total number of the sample. Okay, so here we have on the left side the population mean, which is everybody in that particular population. Okay, so mu equals the sum of all x, capital X, over capital N. The sample mean is x bar equals the sum of x, it should be little x, over lowercase n. Okay, so mu, it represents the population mean. Large N is the number of values in the population. X represents any particular value. This is the sum sign, indicates the operation of adding. So it's the sum of all the x's. The sum of x is the sum of the x values in the population. That's for the population mean. In the sample mean, you have x bar, which is the sample mean. It is x bar. N, small n, lowercase n, is the number of values in the sample. Okay? These formulas are good to know, and as I mentioned a couple of classes ago, basically there's a formula sheet which you can use whenever you have an evaluation that requires it. I feel that you don't know, you have to understand the concept, you have to know what the formula is, but you don't have to manually do the formula. So you can do it on the computer, you can do it on your calculator. So in this example, we have Suncom is studying the number of minutes used monthly by clients in a particular cell phone rate plan. Yes, that's the 30-page sheets of formulas I posted, which covers all 8 chapters. So a random sample of 12 clients showed the following number of minutes used last month. Again, I am going to emphasize that 12 is not really an adequate number, but for the sake of demonstration, in this example, they're using 12. Okay? Later on, we're going to talk about how to find an appropriate sample size. There's a formula for that. Okay? But in this case, we have 12. They show the following number of minutes used in the last month, and then you see them, no particular order. So what does the arithmetic mean? You know, this is the mean now. When you were in high school, you had X number of subjects. You got a grade on each subject. You added them up, divided by the number of subjects you take, and you got an average or the mean. That is an arithmetic mean. Okay? So showing the formula at the bottom, we've got the mean equals the sum of x over n equals, and we add up, in this case, all the minutes divided by the total number of observations. That's another name for sample. The sample size is 12. Okay. We get 1170 divided by 12 equals 97.5. So when you get that number, I can say, okay, in a random sample of 12 clients, the average number of minutes used for the month of August was 97.5. Okay, is that it? Is that good? Does that tell you everything? What else would you like to know there? No one. Everybody thinks this is a good measure, and you're finished with your study. Is that it? The highest and the lowest? Yeah, because the difference between the highest and the lowest is referred to as the range, and the highest tells you, sort of what is the maximum number that people are on the phone for? What is the lowest minimum number that people are on the phone for? So in this case, we can quickly look at it. 77, right, Jatin? And the highest was 119, right? Okay. And the difference between that is what? 42? Am I correct? Yes. Okay. Okay. Again, what else can we look at? Would you say 97.5 minutes per month? Is that high? Is that low? Is that average? What is it? You just telling me, look at this data. Is 97.5 minutes, is that a high amount? Is that a low amount? How many minutes do you spend on the phone a month? Anybody? Midpoint? Yeah, okay. When you get your bill, does it not say how many minutes you spent? I believe it does. It says how many minutes or connect time. I think that's what it's referred to. Is 97.5, is that an average kind of like time? I really don't know. So I'm asking you, if there's anybody out there that thinks that 97.5, yeah, that's probably an average time you spend on the phone. No one? Okay, these are the kinds of questions you have to ask yourself about the data, because just knowing what the mean is and knowing what the range is not telling you enough. Because who do I compare these people to? What am I going to do? Or is this just a way of finding out, how to calculate, because that's what it appears to be. So I want you to think in a statistical perspective. Like, you want to get as much out of this information as possible. It's not too much. Okay. So yours was 93 last month. Well, then you're sort of close to the average in that example. Okay. The sample mean is from a group of observations is an estimate of the population mean, because unless you have unlimited money and unlimited time, you cannot collect information on a total population. So given a sample size of n, which is your sample, the number of observations, you consider n independent random variables, x1, x2 to xn, each corresponding to one randomly selected observation. And the sample mean is defined to be x bar equals 1 over n times x1 plus x2 up to x plus n. And in real numbers, you have the sum of all the values in the sample and the number of values in the sample divided by the number of values, and it comes out to the same. So what they're saying is, this is a sample, okay? Unless it's the population. So if it's the population, and what you really want to do is you want your sample mean, because at the end of all this, and you say, yes, this group is like, this is their mean, and it was statistically significant. You want that mean, because what you're saying at the end is your sample mean is as close to the population mean as possible. Okay, because that's why you take a sample, and that's why you want your sample to be representative of the population, and that's why you have to be careful when you select the data. All right, so some of the data that I've put out for, if you choose to analyze that data, is data collected by the city. So I'm not concerned, I'm not saying that it's the population, but in some cases, for example, they have all the dog and cat licenses in the city of Toronto as of 2017. That doesn't mean that everybody who has a pet, dog or cat, registered. So there may be some people that are not registered, but we don't know that, okay? It's only as much as the organization that's collecting the data can get. If somebody's not willing to provide that information, then you have no idea if that information exists or it doesn't exist. But you make the assumption that it is the population. Any questions about that? There's no questions. Okay. So we'll stop there. And as I said, tomorrow's office hours, we can discuss Chapter 2 if you've got any questions about Chapter 2. And I have not received, let's just put it this way, a large number of homework assignments. So if you get them in, that would be great. And that's it for today. Sorry about the sound at the beginning, and hopefully for those people that are not familiar with measures of central tendency, this is making sense to you. Otherwise, I'll direct you to the text and read or start reading Chapter 3. And remember, the test on Chapter 2 will be starting on Friday at 5 till Monday at 5. Okay, everybody have a good evening. Enjoy the nice weather. And I'll see some of you hopefully tomorrow. May not. Otherwise, we'll see everybody on Friday. Okay? Thank you. Take care.